Imagine sitting in a quiet mountain valley. It's a warm afternoon, maybe a little humid. Then, within minutes, the sky turns pitch black and a wall of water, not just heavy rain, but a roaring, unstoppable torrent, comes crashing down the mountainside, washing away bridges and sweeping up cars like twice. This isn't just a heavy rain. This is a cloudburst. In places like the Himalayas, these events can dump over 100 millimeters of rain in a single hour over a tiny area. But what actually causes nature to turn on a giant fire hose in the middle of the sky? And why does it happen almost exclusively in the mountains? Let's break down the science. To understand a cloudburst, you have to look at the atmosphere like a pressure cooker. It all starts with three key ingredients, which are massive moisture, steep terrain, and extreme updrafts. Huge amounts of warm, humid air are dragged from lower plains or oceans straight toward the mountains during the monsoon. As this heavy air hits a steep mountain wall, it has no choice but to go up and fast. As it rockets upwards, it cools down rapidly, condensing into giant cumulonimbus storm clouds. This is where the magic and the danger happens. Inside these towering clouds, extremely violent upward winds or updrafts blow straight from the ground into the sky. These updrafts are so strong that they suspend tons of water droplets and ice crystals high in the air, preventing them from falling. The cloud essentially becomes an overloaded water reservoir held up by the sheer wind. Eventually, the updraft weakens or simply gets overwhelmed by the crushing weight of the water it is holding. The atmospheric dam breaks. Everything held in the cloud crashes down at once, causing a hyper-localized deluge. Now, if moisture and storms happen everywhere, why do we mostly hear about cloudbursts in the Himalayas? Why don't they happen on the flat plains or the plateaus of central India? It comes down to extreme geography. Because of the vertical relief, the Himalayas are the highest and the steepest mountains on earth. Warm air hitting them doesn't just climb, it is violently shoved thousands of meters up into the freezing atmosphere in minutes. The next is the funnel effect. The mountains are carved by deep, narrow river valleys. These valleys act like natural wind tunnels, channeling moisture-laden air deep into the mountains and squeezing it upward at incredible speeds. Because the altitude changes so drastically over a short distance, rising warm air instantly hits freezing cold upper air, and this causes immediate explosive cloud condensation. During monsoon season, regional winds often collide with upper air systems like western disturbances, creating severe atmospheric instability that triggers these massive suspended updrafts. Okay, this was the answer to the question that why it happens mostly in Himalayas only. But what about the plain areas? I'll answer that. The flat plains like the Indo-Gangetic basin lack these physical barriers, meaning air rises gradually over flat ground, producing steady, widespread rain instead of a sudden, localized explosion of water. So I hope you are able to understand this phenomena. This isn't just a textbook phenomena, it has very real devastating consequences. In recent years, regions like Jammu and Kashmir, Uttarakhand and Himachal Pradesh have seen a worrying surge in these events. In Jammu and Kashmir, regions like Kishtwar and Shopian have faced clusters of sudden deluges, causing severe flash floods and disrupting communities. In Uttarakhand, powerful cloudbursts around Uttarkashi and Dharali have repeatedly swept away homes, bridges, and infrastructure, isolating remote villages. And similar destructive patterns have battered Himachal Pradesh, Mandi, and Kullu valleys. Because cloudbursts happen over tiny areas, sometimes just a few square kilometers, they are notoriously difficult to forecast accurately, making early warning systems a massive challenge for scientists and disaster management teams. At last, I would like to say that cloudbursts are a stark reminder of the immense raw power of nature, where geography, moisture, and atmospheric physics collide in the most dramatic way possible. Understanding how they happen is the first step towards better preparedness in India's fragile mountain ecosystems. If you found this video informative, make sure to hit that like button, subscribe for more geography breakdowns, and drop a comment below on what topic you want us to cover next. Thanks for watching and